part 2 of our 4-part series on electricity from generation to the meter. In this video, we will cover the transmission process. Our goal for the series is to share each process in a simplified manner that everyone can understand. With that said, let's get started. As we covered in part 1 of the series, electricity is created at a power plant. Once electricity is generated, it leaves the power plant through large wires that are referred to as transmission lines. The transmission lines are like a highway for the electricity. They disseminate bulk amounts of very high voltage electrical energy over long distances. The electrical energy is distributed at voltages of 115 kilovolts or above to reduce energy loss. The main components of the electricity highway are wires that the electricity travels through, poles and towers, which are the support structures that keep the wires suspended high in the air, and substations, which are the checkpoints and conversion stations along the way. Transmission power is normally distributed overhead from tower to tower until reaching a substation. However, although it's uncommon, there are some underground transmission lines. Substations are where transmission lines connect to transmission lines, or where transmission lines are converted to distribution voltages. There are different types of substations. For this video, we'll cover transmission and distribution substations. Transmission substations connect 2 or more transmission lines. Transmission substations contain devices such as high voltage switches to allow for switching or isolating lines, transformers to convert between voltages, protection and control equipment, and correction devices and phase shifting transformers to control power flow. Distribution substations use transformers to transfer power from transmission voltages of 115 kilovolts and above down to distribution voltages suitable for local distribution, which range from 2.4 kilovolts up to 33 kilovolts. Distribution substations also serve as voltage regulation points and as points to isolate lines in order to locate faults or de-energize sections. This concludes our coverage of the transmission process. To find out about the distribution process, please watch part 3 of our 4-part series. And free resources for electric utility professionals, visit us